In the last presentation, we looked at adding whole numbers. So we're going to continue with our operations. Our next operation is going to be subtraction. This comes from section 1.3 of the textbook. Let's go ahead and get started. So let's just start off with some basic information. The first thing we have is our notation. Our notation for subtraction is going to be the minus sign. We have some vocabulary, and I'm just going to give you all the vocabulary, but I'm going to point out the ones that you do need to know. So for subtraction, we have three different terms. We have the first one is minuend. This is the first number in a subtraction problem. So for our notation example, A is called the minuend. The second number in a subtraction problem is called the subtrahend. And the one that you do need to know is you do need to know difference. Difference is the result of subtracting two numbers. So C is going to be our difference. Some other words and phrases that you might want to keep in mind is minus, subtracted by, less than, subtracted from, or if you're being asked to find out how much more or how much larger, how much smaller, those are also going to be words that mean subtraction. Properties of subtraction. One thing to note is subtraction is not commutative or associative. Order and grouping matter. So we have to keep that in mind. Some properties that we do have subtracting by 0. Anything minus 0 is itself. We also have the result of subtracting two numbers that are the same. If you subtract two numbers that are the same, the result is 0. All right, so let's go ahead and look at some subtraction problems now. The next thing we want to look at is the relationship between addition and subtraction. So addition and subtraction are very closely related. We're going to see when we get into sign numbers that they are actually almost the same operation, but they are opposites of each other. So we want to examine this relationship between addition and subtraction. So if we look at the first example, we want to rewrite two equivalent statements using subtraction. So how can I rearrange these numbers into a subtraction problem using the same ones? So the first way that I can do this is I can say 11 minus 7 equals 4, or I can also say 11 minus 4 equals 7. We can do the same thing going the other way. If we look at the second example, we want to rewrite two equivalent statements using addition. So I can go ahead and say 13 plus 5 equals 18. Or remember that addition is commutative, I can also write this as 5 plus 13 equals 18. So one thing to note is if you want to subtract or if you want to check your subtraction problems, you can always do it using addition. The first number in a subtraction problem is the total, and the second number is one of the add-ins, as is the result. Now, just like we did with addition, we had two different categories. Same thing's going to happen when we talk about subtraction. So the first category that we're going to look at is subtracting without regrouping or borrowing. Our procedure is going to be similar to our addition. We want to line up our similar columns vertically. Starting on the right, we want to subtract straight down. Again, if it's not a problem that involves regrouping, it doesn't matter what order you go in, but when we get into mixing these problems together, it's going to be hard to determine whether we need to start on the left or the right, and so it's always a good idea just to start on the right and go from there. Okay, so example A. We have 53 minus 21. I want to line up my columns starting on the right. We want to line up our ones columns, our tens columns, etc. And then from there we want to go ahead and subtract straight down. So starting on the right, 3 minus 1 is 2. 5 minus 2 is 3. So we get an answer of 32. All right, let's look at example B. Again, I want to line up my numbers. So I'm going to put 385 on top with 165 on the bottom. And then if we go ahead and subtract, starting on the right, we get 5 minus 5 is 0. 8 minus 6 is 2. 3 minus 1 is 2. And we're done. All right, last example. I'm going to put my 9437 on top. I'm going to put my 210 on bottom. One thing to note on this is they have a different number of digits. So remember that we want to push it as far to the right as possible. We want to line up according to the right digits. And then from there we want to go ahead and subtract starting on the right. So we get 7 minus 0 is 7. 3 minus 1 is 2. 4 minus 2 is 2. And we bring down our 9. All right, that takes care of subtraction without regrouping or borrowing. Let's talk about subtraction with regrouping or borrowing. So one thing to note is, same idea as before, we're going to line up similar columns vertically. One thing I forgot to mention in the last slide is you always want to make sure your larger number is on top. That's going to be important when we get into sign numbers. For this module, the larger number is always going to be the first number. But when we get into application problems, just remember larger number always goes on top. All right, from there we want to, starting on the right, we're going to subtract straight down. We want to note if the number on top is smaller than the number on bottom, we're going to borrow from the column directly to the left. To do this, we're going to subtract 1 from the left column and add 10 to the column on the right. All right, so let's look at some examples of this. Example A, we have 57 minus 19. I'm going to go ahead and write this vertically. This is another time that you want to go ahead and kind of write larger. Spread out your numbers a little bit more so you can see your columns, and more importantly, so it's a little bit easier to see your borrowing when we do it. Okay, so can I do 7 minus 9? No, we cannot. Okay, 7 minus 9 is not the same thing as 9 minus 7. You can't just go back and forth. We always have to do top minus bottom. I cannot take 9 away from 7, so we have to borrow. So in order to do this, I'm going to borrow from the 5. The 5 is going to become a 4. And the 7 is going to become a 17. Now I can subtract 17 minus 9. 17 minus 9 is 8. And now 4 minus 1 is 3. So our final answer is 38. Okay, let's try a couple more. Let's look at example B. Example B, I want to do 635 on top minus 546 on the bottom. Can I do 5 minus 6? Can I take 6 away from 5? The answer is no. So we do need to borrow. I'm going to take 1 away from the 3 and make it a 2. I'm going to add 10 onto 5 and make it a 15. Now I can do 15 minus 6. 15 minus 6 is 9. And we move to the next column. Can I do 2 minus 4? Can you take 4 away from 2? The answer is no. So again, I'm going to borrow from the 6. The 6 becomes a 5. The 2 becomes a 12. 12 minus 4 is 8. And 5 minus 5, those cancels, they give me 0, but we don't have to write it in our answer. Our final answer is 89. All right, example C. I'm going to start by putting my 675 on top. I'm going to push my 86 on the bottom. Again, I want to push it to the right so that my ones columns line up. And we go ahead and subtract. Again, I can't do 5 minus 6, so I need to borrow. The 7 will become a 6. The 5 will become a 15. 15 minus 6 is 9. We move to the next column. Can we do 6 minus 8? You cannot take 8 away from 6, so we need to borrow again. My first 6 becomes a 5. My second 6, we're going to add 10 onto it. It becomes a 16. So 16 minus 8 is 8. We move to the next column. 5 minus nothing is 5. All right, so those are some examples there. Let's go ahead and look at some examples where we have extended borrowing. All right, example D. We have 4,607 minus 3,168. We're going to go ahead and line this up. I'm going to put my 4,607 on top, my 3,168 on the bottom. Now this next set of examples, these are going to involve extended borrowing. So we're going to see what that looks like. So if we go ahead and do what we were doing before, we get 7 minus 8. I cannot do 7 minus 8, so I have to borrow. Can I borrow from 0? Well, the answer to that is no, because it's 0. So we need to extend over and borrow from the 6. So we're going to make 6 into a 5. The 0, we're going to add 10 onto 0, it becomes 10. And now I can borrow from 10. 10 becomes a 9, and 7 becomes a 17. Now we can go ahead and subtract. So we get 17 minus 8 is 9. We want to look at the 9. Minus the 6 becomes 3. We want to do 5 minus 1 is 4. And 4 minus 3 is 1. So our final answer is 1,439. All right, example E. We have 708 minus 149. So I'm going to put my 708 on top. I'm going to put my 149 on the bottom. And then we subtract. Again, can I take away 9 from 8? The answer is no. So we do need to borrow. We cannot borrow from 0, so we need to go all the way to the 7. So if we take away 1 from 7, it becomes a 6. I add 10 onto 0, that's going to make it a 10. We subtract 1 from 10, it becomes a 9. And my 8 becomes an 18. So 18 minus 9 is 9. 9 minus 4 is 5. And 6 minus 1 is 5. So our final answer is 559. All right, last example we have is 9,000 minus 6,999. So this is going to be kind of the epitome of our borrowing problem. I'm going to put my 9,000 on top, my 6,999 on bottom. Starting on the right, can I do 0 minus 9? Can you take away 9 from 0? And the answer is no. So we do need to borrow. Well, can I borrow from here? The answer is no. 0, you have nothing to borrow from. So we need to go over one more digit. Same thing here. I can't borrow from 0. So we're actually going to have to go to the very front of the number and borrow from the 9. So if we do that, we're going to subtract 1 from 9. It becomes an 8. My first 0 becomes a 10. Now I can borrow from it, so it becomes a 9. My second 0 becomes a 10. I can borrow from it, it now becomes a 9. And my third 0 now becomes a 10. Now we can subtract. So starting on the right, we get 10 minus 9 is 1. Moving to the left, we get 9 minus 9 is 0. 9 minus 9 is still 0. And 8 minus 6 is 2. All right, so that takes care of subtracting with borrowing or regrouping. Okay, so now let's go ahead and look at some application problems. So the main thing that we want to do is we want to identify the wording that tells us the problem involves subtraction. We're going to translate to a mathematical model and then solve. So example A, we have a woman burns 302 calories during an hour of walking, while a man burns 403 calories doing the same activity. How many more calories does a man burn than a woman during an hour of walking? So, what makes this a subtraction problem? This is a subtraction problem because we have that phrase, how many more? Remember that's how much do I have to add on? And when you're asking how much do you have to add on, that implies subtraction. So now we want to go ahead and set up our problem. Remember that on the previous slide, I said that when subtraction, larger number always goes on top. So to set up this problem, I want this to be 403. That's my larger number. Minus 302 will go on the bottom. So we can go ahead and subtract now. Starting on the right, we get 3 minus 2 is 1. 0 minus 0 is 0. And 4 minus 3 is 1. We also want to include correct units. So what are we looking at here? We are looking at calories. So this is going to be 101 calories. All right, let's look at example B. It says in 1964, the Ford Mustang sold for $2,500. In 2017, the Ford Mustang sold for $33,628, and we want to find the increase. So again, find the increase. This is our phrase that tells us this is a subtraction problem. I want to know how much do you have to add on to the original price, $2,500, in order to get $33,628. So this is a subtraction problem. The first thing I want to do is I want to put my larger number on top. So this is going to be 33,628 minus 2,500. Again, make sure that you push the 2,500 over to the right so that your ones columns line up. And then we go ahead and subtract starting on the right. So we get 8 minus 0 is 8. 2 minus 0 is 2. 6 minus 5 is 1. 3 minus 2 is 1. And we bring down our 3. The last thing we need is our units. We are looking at dollars, and so my final answer is going to be $31,128. All right, that takes care of example B. Okay, for example C, we have eye exams have been given to 14,679 children in the school's district. If there are 23,156 students in the district, how many have not received eye exams? So this one, the main thing to note here is that we have a total. We are given the total. And it's divided into two categories, people who have gotten eye exams and people who have not. If you combine those two, you get the total. We are looking for a part of the whole, so this is going to be a subtraction problem. So again, I want to start by putting my larger number on top. This is going to be 23,156. And I want to subtract my 14,679. So starting on the right, we're going to go ahead and subtract. Can I do 6 minus 9? Can I take 9 away from 6? The answer is no. So we're going to go ahead and borrow from the 5. It becomes a 4. 6 becomes a 16. And we subtract. 16 minus 9 is 7. And we move to the left. Can I do 4 minus 7? Can I take 7 away from 4? The answer is no. So we need to borrow. My 1 becomes a 0. We add 10 onto the 4. It becomes a 14. 14 minus 7 is 7. And we move to the left. Can I do 0 minus 6? Can I take 6 away from 0? The answer is no. So we need to borrow. We're going to take 1 away from 3. It becomes a 2. And my 0 becomes a 10. 10 minus 6 is 4. And we move to the left. Can I do 2 minus 4? No. So we need to borrow. I'm going to take 1 away from the 2. It becomes a 1. My second 2 becomes a 12. 12 minus 4 is 8. And if we move to the left, 1 minus 1, they cancel, so we don't need to do any subtraction there. We need to include our correct units. In this problem, it's going to be children. So our final answer is 8,477 children. All right, that takes care of our subtraction examples. In the next section, we will look at multiplication. So go ahead, take a break, and I will see you again shortly for that.